Alright, here is example 1. I'll go ahead and shoot this one and then do example 2 as a different video. That way they're a little bit shorter. So I have 1x cubed minus 6x squared plus 11x minus 6 is equal to 0. It's important that that does equal 0. Everything needs to be on one side. I just prefer the left-hand side. This says A, use the rational root theorem to determine the roots or solutions or zeros or intercepts. And then B, state the end behavior with arrow notation. I'm going to go ahead and do that first. And I have my two blanks I need to fill. This is a positive function on my highest exponent of 3. So that means the right side is positive going up. It is an odd exponent. Odd exponent means opposite, so the other arrow is down. That's my end behavior. I'm going to erase that so that it is cleaned up. Go ahead and clean up the rest of this, make it look nice and shiny. And back to drawing. So now, using the rational root theorem means P over Q. So 1 is my Q, and the factors are 1 and 1. And then for 6 is my P, and my factors of 6 are 1, 2, 3, and 6. So when I do my P over Q list, I have 1 over 1, 2 over 1, 3 over 1, etc. So everything's going to be over 1. So it's really just plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, comma, plus or minus 6. So now I need to use those values to figure out which ones might actually be a factor of that. So going into synthetic division, I have 1, negative 6, 11, and negative 6. Starting with a positive 1, bring down that 1. 1 times 1 is 1, negative 6 and 1 is negative 5, and positive 1 times negative 5 is a negative 5, 11 minus 5 is 6, 1 times 6 is 6, and that gives me 0, so that tells me that that indeed is a root. So far I have x equals 1. So now let's change up just a little bit here. I'm going to go back to purple. Let's change to blue. I'm going to use these values in my next synthetic division. So 1, negative 5, 6. I need to get it through my head that blue and purple are not that different. I am going to go back and use positive 1 again, just to make sure it's not a double root. So 1 times 1 is 1. Negative 5 plus 1 is negative 4. And 1 times negative 4 is negative 4. That is not going to give me a root. So I have 1, negative 5, and 6 going back to my original. Going back to this set of values. Let's do red. I am going to use a negative 1 this time. So bring down the 1 is 1. Negative 1 times 1 is negative 1. Negative 5 minus 1 is negative 6. Negative 1 times a negative 6 is a positive 6. That gives me not a 0. So going back to 1, negative 5, 6. I'm going to use a positive 2. Bring down the 1. 2 times 1 is 2. Negative 5 plus 2 is negative 3. Positive 2 times negative 3 is negative 6. That gives me 0. So that too is a root. So that is x equals positive 2. I can now take 1 and negative 3. That is 1x minus 3. I set that equal to 0. I add 3 to both sides. So I have x equals 3. So my last root is x equals 3. So those are my roots. Done with that problem. I'll do example number 2, which is below this one, in just a moment. Let me get this done.